Hello everyone and welcome to another Ask IoT video series episode presented by IoT for All. I'm Ryan Chacon, and on today's episode we're going to talk about power over Ethernet. And with me today is Erin Kelly, the creative director at Cence Power, formerly Argentum. Some of the episodes we've done in the past are from when they were known as Argentum. But they are the world's first all-in-one DC power distribution system company. And fantastic episode. You get a lot of value out of this one. Please be sure to subscribe to our channel if you have not done so already. Give this video a thumbs up and hit that bell icon so you get the latest episodes as soon as they are out. But other than that, on to the episode. Welcome, Erin. Thanks for taking some time to chat with me today. Appreciate it.
Yeah, happy to. Thanks for having me.
Absolutely. Let's kick this off by having you give a quick introduction about yourself as well as the company.
Yeah, sure. So my name is Erin. I'm the marketing lead at Argentum, and I also do a lot of the content research and stuff for the blogs and everything like that. So yeah, that's where I got a lot of my knowledge about technology, just doing research about it for the blogs and also from talking to my colleagues. And Argentum, I guess you want to know about the company too. We distribute DC power to buildings. Like we have a system that's kind of like plug and play for DC power distribution and makes buildings more efficient. That's basically it.
Fantastic. All right. So today we have a couple things we want to talk about. We want to talk about power over Ethernet, what that is, kind of what people need to know about that, high and low voltages, or I guess high versus low voltages, and then DC versus AC power. Let's kick it off by having you just give a quick overview of each of those, just so we can kind of start there.
Okay, so you said that you want an overview of power over Ethernet and then AC versus DC and high and low voltages of those?
Yeah, let's start with power over Ethernet and just kind of tell our audience what that is and again, let's try to discuss this from a not as technical, so maybe people who are not as technical could kind of understand, and when they hear power over Ethernet, they understand what it is and kind of the value it plays.
Yeah, of course. All right, sure. Let's start with power over Ethernet. So power over Ethernet, or PoE, it's been popular basically for a couple decades now, like for 2 or 3 decades. And the most recent type of PoE came out in 2018. It's the one that provides the most power, which is 90 to 100 watts per cable. And the interesting thing about PoE is that it delivers both data and power through one single cable. So this was a really big problem that people needed solved in the 90s and early 2000s, so that they could cut back on installation costs, because a lot of the time, and also like they wanted to improve the simplicity of installation too for certain types of devices. So installing power over Ethernet, or PoE, kind of allowed people to install one cable that delivered both power and data, rather than installing 2 lines of cable, one for power and one for data. So that's the gist of it.
And when you're talking about the wattage that it's able to deliver, for our audience out there, can you explain kind of what types of devices it can provide power to, or maybe where it's limited from a power standpoint? I'm not sure most people know exactly like the wattage requirements for certain things to be powered, but if you could maybe explain what it's most often used for.
Yeah, for sure. So power over Ethernet is mainly used for, like, it can be used for a lot of PoE-based lighting, which is very low voltage lighting. And it's also used for something called VoIP phones, which are not used so much anymore, but they were used a lot back in offices. If you're a millennial like myself, you could probably imagine one. They've got like, speed dial.
Yep.
Like applicate. Yeah. Maybe put a picture on the screen or something.
Yeah.
Also used for security cameras. That's a really big application for them, just so that data of the video, like the display of the video camera, can be displayed, and also the camera can be turned on, like powered. Gotcha. So those are some really big applications.
Fantastic. All right, so we talked about PoE. Let's talk about high versus low voltages and AC versus DC power. I guess break them up however you feel is necessary, just to kind of explain their role and what's important for people to know about both those topics.
Yeah, sure. So I guess one of the most important things to know about electricity and about high voltages versus low voltages is that, first of all, there's 2 different types of electricity. There's alternating current electricity and direct current electricity. Alternating current is what our power grids deliver. It's what's generated a lot of the time. And it's probably the type of power that's running through your walls, unless you have some kind of a DC power microgrid. So a DC power microgrid would be powered by like solar power, because solar power generates DC electricity, whereas most other generators generate AC electricity. AC is used basically because it won the current wars back in the late 1800s. Uh, Basically, Nikola Tesla, he vouched for AC power, and he was able to create this thing called an AC induction motor, and that helped him. That motor, like the invention of that motor, kind of like sparked the second industrial revolution and allowed electricity to be distributed at longer distances. So that's why we use the AC. That's why we use AC power right now, and also a lot of different appliances and stuff back in the late 1800s and throughout a lot of the 20th century were powered by AC electricity, like incandescent light bulbs and that kind of thing. But now we're getting more digital devices, and digital devices, because they use semiconductors, and semiconductors are powered by DC electricity, that means that a lot of our modern day devices actually require DC electricity. So when they're getting AC electricity, it kind of creates a little bit of like a discrepancy, like when they're getting AC electricity, they're wasting energy converting that AC electricity into DC electricity whenever they receive that AC electricity, and that can waste a lot of energy when devices are doing that at an individual level every time they're turned on.
Fantastic. Yeah, I was actually I was just up at Niagara Falls recently, and there's a whole thing there about Tesla and the power that they were able to generate from the waterfalls and that whole
Mhm.
basically all the revolutionary things that happened up there. So it was very very fascinating to kind of I got a quick like 5 minute intro into kind of what he built and how they were able to transmit power over long distances. I think they displayed it. I don't know if it was like at the World Fair or something like that.
Yeah.
And yeah, it was very cool. Kind of learn that in that setting.
Yeah. Yeah, that's a huge part of our history. Like, imagine how many like devices we have these days, and where our world would be if we didn't have electricity. Like, we wouldn't be able to make coffee in
Yeah.
the morning, or
Right.
like power our homes, or have HVAC systems that gave us
Yep.
air conditioning and heating and everything. Yeah, like electricity is such a major part of our lives, and I think we really take it for granted sometimes. But it's really cool to learn about that
Yeah.
history and where it came from.
For sure. So, how does the high versus low voltage kind of conversation fit into all this?
So AC electricity is distributed to our homes, as I mentioned, and that's actually just because it's more efficient to distribute high voltages of AC electricity. And
Mm,
the reason it's more efficient is not because it loses less power along cables. Actually, DC power loses less power along cables, like while it's traveling. AC electricity is more efficient to transmit basically because the infrastructure for AC power systems and distribution systems is more
mm,
cheap than the infrastructure for DC
gotcha.
distribution systems. So AC distribution systems can just use a transformer to step up and down voltages. Basically, you need to have very high voltages to distribute power across long distances. And then you need to step down those voltages to lower voltages for distribution throughout communities and through buildings and that kind of thing. So you really need to make that process easy. And with DC electricity, you can't really make that process very easy. It's more expensive because you have to build these things called rectifier stations, which would change the DC electricity into AC electricity. And then from there, a transformer would be used to step down voltages.
Gotcha.
So it's two things rather than one thing when you create a DC power distribution system. And so that's where the high voltages thing comes in. But in a lot of cases, there are DC transmission systems, which are different than DC distribution systems. We don't really have DC distribution systems. We really just have DC transmission systems because we can only justify the transmission of DC electricity at very high voltages and very long distances. It's actually the break-even distance of 600 kilometers. And if you're transmitting 600 kilometers or more power, then people build high
Mm,
voltage DC systems, which are also called HVDC transmission systems.
gotcha.
So we have like hundreds of those transmission systems in the world today, but even then, power from those systems is like transformed to it's changed to AC power and then stepped down with the
Gotcha.
transformer. So basically, like AC power is still being distributed throughout communities, even when it's coming from a DC
Mm,
transmission system.
okay.
And that's why buildings today are getting AC power.
Fantastic. Yeah, this is
Yeah.
I'm learning a lot. I think we discussed some of this on in the podcast episode you did with us too, and just fascinating to learn a lot about the stuff we probably take for granted and don't think about too much on a daily basis. Um,
Mm-hmm.
I did want to ask, kind of as we wrap this up, just as it relates to the IoT space, you mentioned that I guess it makes sense on how PoE works, bringing power and that connectivity being one that's plugged into a device. But you mentioned how DC power is kind of playing a role in a lot of these devices as well. But just generally speaking, all the topics we've talked about today, how do they really, or I guess what should people really be thinking about in the role they play in the IoT space?
Yeah, I think for this, I should probably connect the two things that I talked about. Like I talked about PoE and I talked about high voltage DC versus AC.
Yeah.
Basically, like when AC power goes into your building, it's distributed throughout all of your devices and that kind of thing. And when you have a smart building, then you have a lot of digital devices that require DC power. And so if AC is going to these devices, then these devices are wasting a lot of electricity by converting AC power to DC power. And this isn't done by a converter that's connected to the device. And usually these converters are relatively inefficient because they don't actually have efficiency requirements if they are less than 45 watts. So that's why like the manufacturers don't really need to make the converters very efficient when they're creating converters to convert AC to DC electricity on an individual load. So when we have a smart building and we have all of these DC digital devices, it's better if DC power is distributed directly to them. And then that's where like DC power distribution comes in, and PoE is a DC power distribution system. So if you plug in like power over Ethernet, then it will distribute DC power to your devices. But a lot of the time devices are not made to be compatible with PoE. Like they need to be PoE compatible devices in order to work with power over Ethernet. So that is really like the big problem that's being solved right now with class 4 power systems, for example. And I don't know if you want me to get into class 4 power systems, but they're basically a type of power system that has more power capabilities than PoE, but uses the same safety requirements as PoE.
Gotcha.
And that's because they're fault managed rather than power limited circuits. And I could explain that further, but I feel like I just want to like skim the very surface because it's already a lot to digest. Yeah.
No, this has been fantastic. I really appreciate you taking the time to do this. For our audience who may have questions about this, learn more about what you all do, and this just kind of maybe touch base in general. What's the best way they can do that?
So they could go to our website. We have lots of blog posts on there. I wrote a ton of blog posts to explain all of these different concepts further, from high voltage DC to class 4 power systems. Our website, I guess you'll put the link at the bottom there. They can also find us on LinkedIn, and we're also on YouTube. We explain a lot of these concepts on our new YouTube channel called Electric Insights, so you can check that out too.
Fantastic. Well, thanks so much for your time. Really appreciate it.
Yeah, of course. Thanks for having me.
All right, everyone. Thanks again for watching that episode of the Ask IoT video series. I hope you found a lot of value in it. If you did, please be sure to like the video and subscribe to the channel. It helps others find it and make sure that you get the latest episodes as soon as they become available. Other than that, if you have any questions or topics that you would like us to cover in this series, please leave them in the comments or shoot us an email at hello@iotforall.com. Other than that, thanks again for listening, and we'll see you next time.